welcome to another Android tutorial. My name is Nicholas Nikolic, and you are listening to the Android Book Tutorials. These tutorials are based on the Creative Commons work of Mark Murphy, who kindly releases versions of his book, The Busy Coder's Guide to Android Development, and as such are released Creative Commons here as well on YouTube. I'll read from the book and go through the points directly. You might be warned at this time that I cover up to Android 4.4 only, whereas the original subscription book is updated on a quarterly basis for Android 6 and beyond. For a completely current version of the book, and for a completely current version of Android, please purchase a subscription to the Murphy book at commonsware.com. Key Android concepts. No doubt you are in a hurry to get started with Android application development. After all, you are reading from this book aimed at busy coders. However, before we dive into getting tools set up and starting in on an actual programming, it is important that we get on the same page with respect to several high-level Android concepts. This will simplify further discussions later on in the book. Excuse me, I need some water. Android applications. This book is focused on writing Android applications. An application is something that a user might install from the Play Store or otherwise download to their device. That application should have some user interface. It might have other code designed to work in the background, multitasking for instance. This book is not focused on modifications to the Android firmware, such as writing device drivers. For that, you need to seek other resources. This book assumes that you have some hands-on experience with Android devices, and therefore you are familiar with buttons like Home and Back, and built-in settings application, and the built-in settings application, the concept of a home screen launcher, and so forth. If you've never used an Android device, you are strongly encouraged to get one. For example, a used one on eBay, Craigslist, etc. And spend some time with it before starting in on learning Android application development. Programming language. The vast majority of Android applications are written exclusively in Java. Hence, that is what this book will spend most of its time on, and will demonstrate with a seemingly infinite number of examples. And he means it. This book is about 3,000 pages long. However, there are other options. You can write parts of the app in C, C++ for performance gains, porting over to existing code bases, etc. You can write an entire app in C, C++, mostly for games using OpenGL for 3D animations. You can write the guts of an app in HTML, CSS, and JavaScript using tools to package that material into an Android application that can be distributed through the Play Store and similar venues, and so on. Coverage of these non-Java alternatives will be found in the trails of this book, as the bulk of this book is focused on Java. The author assumes that you know Java at this point. If you do not, you need to learn Java before you go much further. You do not need to know everything about Java, as Java is vast. Rather, focused on language fundamentals, flow control, etc., classes and objects, methods and data members, public, private, and protected, static and instance scope, exceptions, thread, collections, generics, file I/O, reflection, and interfaces. The links are to wiki books related on these topics. These are actual links he has here in the text. Though there are countless other Java resources for you to consider. Components. When you first learned Java, whether that was yesterday or back when the dinosaurs roamed the earth, you probably started off with something like this. Class, silly app, public static, void, main, string, args, string array, args, system out, print line, hello world. I'll work on how to show code. I might actually throw images up. We'll figure it out. I'll figure it out. Don't worry about In other words, the entry point for your application was public static void. Was a public static void method named main that took a string array of arguments. From there, you were responsible for doing whatever was necessary. However, there are other patterns used elsewhere in Java. For example, you do not write a main method when writing a Java servlet. Instead, you extend a particular class supplied by a framework. For example, HTTP servlet to create a component. Then write some metadata that enumerated your components and tell the framework when and how to use them. For instance, web.xml. Android apps are closer in spirit to the servlet approach. You will not write a public static void main method. Instead, you will create a subclass of some Android-supplied base classes that define various application components. In addition, you will create some metadata that tells Android about those subclasses. There are 4 types of components, all of which will be covered extensively in this book. The first one, activities. The building block of the user interface is the activity. You can think of an activity as being an Android analog for the window or dialog in a desktop application, or the page in a classic web app. Normally, an activity will take up most of the screen, leaving space for some Chrome pieces of the interface, bits like the clock, signal strength indicators, and so forth. Activities are short-lived and can be shut down at any time, such as when the user presses the back button. Services, on the other hand, are designed to keep running if needed, independent of any activity. Before we go on, I should say, right now you're probably seeing nothing on the screen actually happening, but in further tutorials, I will be, although this book is considering Android 4.4, and at that particular time, the Eclipse Studio, ADT, Android development tools were predominant. I'm going to be switching the tutorials in this book over to Android Studio to keep current. It should be useful, but you'll see. In the meantime, there's little going on the screen. I apologize for that, but just listen along. We're reading along with the book in this chapter. In future chapters, there'll be things going on screen. Content providers, services. Activities are short-lived and they can be shut down at any time, such as when a user presses the back button. Services, on the other hand, are designed to keep running, if needed, independent of any activity for a short period of time. You might use a service for checking for updates to an RSS feed, or to play back music even if the controlling activity is no longer operating. You will also use services for scheduled tasks akin to Linux or OS X cron jobs, for exposing custom APIs to other applications on the device, though the latter is a relatively advanced capability. Content providers. Content providers provide a level of abstraction for any data stored on the device that is accessible by multiple applications. The Android development model encourages you to make your own data available to other applications as well as your own. Building a content provider lets you do that, while maintaining a degree of control over how your data gets accessed. Broadcast receivers. The system or applications will send out broadcasts from time to time. For everything from the battery getting low, to when the screen turns off, to when connectivity changes from Wi-Fi to mobile data. A broadcast receiver can arrange to listen for the broadcasts and respond accordingly. Widgets, containers, resources, and fragments. Most of the focus on Android application development is on the UI layer. And activities. Most Android activities use what's known as the widget framework for rendering their user interface. though you're welcome to use the 2D Canvas and 3D OpenGL APIs for a more specialized GUI. In Android terms, a widget is the micro, in quotes, unit of user interface. Fields, buttons, labels, lists, and so on are all widgets. Your Activities UI, therefore, is made up of one or more of these widgets. For example, here we see label, text view, field, edit, and push button widgets. I'm just going to go ahead and flip this around. Text view, edit text view, button widget, if you have more than one widget, which is fairly typical, you will need to tell Android how those widgets are organized on screen. To do that, you will use various container classes referred to as layout managers. These will let you put things in rows, columns, or more complex arrangements as needed. To describe how the containers and widgets are connected, you will typically create a layout resource file. Resources in Android refer to things like images, strings, and other materials that your application uses, but is not in the form of some programming language source code. UI layouts are another type of resource. You will create these layouts either using a structured tool, such as Eclipse's drag and drop GUI builder, or by hand in XML form. Sometimes your UI will work across all sorts of devices, phones, tablets, televisions, etc. Sometimes your UI will need to be tailored for different environments. You will be able to put resources into resource sets that indicate under what circumstances those resources are to be used. For example, use these for normal size screens, but use those for larger screens. Sometimes supporting larger screens means that you will want to snap together parts of your smaller screen UI. For example, Gmail on a tablet will show you a list of labels. The list of conversions are in a selected label, and the list of messages in a selected conversation all in one activity. However, Gmail on a phone cannot do that. There's not enough screen space. So it shows each of those labels, conversations, messages in separate activities. Android supplies a construct called the fragment to help make it easier for you to implement all sorts of effects. We will be examining all of these concepts in much greater detail as we get deeper into the book. Apps and packages. Given a bucket of source code and a basket of resources, the Android build tools will give you an application as a result. The application comes in the form of an APK file. It is that APK file that you will upload to the Play Store or distribute by other means. Each Android application has a package name. A package name must fulfill 3 requirements. It must be a valid package name from Java, as well as some Java source code will be generated by the Android build tools in this package. No 2 applications can exist on a device at the same time with the same package. No 2 applications can be uploaded to the Play Store having the same package. When you create your Android project, the repository of that source code and those resources, you will declare what package name is to be used for your app. Typically, you'll pick a package name following the Java package name reverse domain name convention. For instance, com.commonsware.android.foo. For those of you new to programming, foo is just a strange word used for examples. That way, the domain name system ensures that you package name prefix com.commonsware is unique. Basically, if you have a website, reverse your top level domain and your domain name, and you get the reverse domain name convention. and it is up to you to ensure that the rest of the package name distinguishes one of your apps from any other. In other words, under your domain, you can't name two things the same thing and get it in the Play Store. Android devices. There are well in excess of 100 million Android devices in use today, representing hundreds of different models from dozens of different manufacturers. Android itself has evolved since Android 1.0 in 2008 between different device types and different Android versions. Many a media pundit has lobbed the term fragmentation at Android, suggesting that creating apps that run on all these different environments is impossible. In reality, it's not that bad. Some apps will have substantial trouble, but most apps will work just fine if you follow guidelines presented in this book and in other resources. Types. Android devices come in all shapes, sizes, and colors. However, there are three dominant form factors: the phone, the tablet, and the television. You will often hear developers and pundits refer to these form factors, and this book will do so from time to time as well. However, it is important that you understand that Android has no built-in concept of a device being a phone, or a tablet, or a TV. Rather, Android distinguishes devices based on capabilities and features. So you will not see an is-phone method anywhere as you do in iOS. Although you can ask Android what is the screen size. Does the device have any telephony capability, etc. Similarly, as you build your application, rather than thinking of those three form factors, focus on what capabilities and features you need. Not only will this make you line up better with how Android wants you to build your apps, but it will make it easier for you to adapt to other form factors that will come about as such. Watches and other types of wearable devices, airplane seatback entertainment centers, in-car navigation and entertainment devices, and so on. The emulator. While there are hundreds of millions of Android devices representing hundreds of models, you probably do not have one of each. You may have only a single piece of Android hardware, but if you do not even have that, you most certainly will have to acquire one before trying to publish an Android app. To help fill the gaps between devices you have and the devices that are possible, the Android developer tools ship with an emulator. The emulator behaves like a piece of Android hardware, but it is a program you run on your development machine. You can use this emulator to emulate many different kinds of devices with different screen sizes and different Android OS versions by creating one or more Android virtual devices, or AVDs. In an upcoming chapter, we will discuss how you install the Android developer tools and how you'll be able to create these AVDs and run an emulator. OS versions and API levels. Android has come a long way since the early beta releases from late 2007. Each new Android OS version adds more capabilities to the platform and more things that developers can do to exploit those capabilities. Moreover, the core Android development team tries very hard to ensure forward and backward compatibility. An app you write today should work unchanged on future versions of Android. Forward compatibility, albeit perhaps missing some features or working in some sort of compatibility mode. There are well-trod paths for how to create apps that will work on both the latest and on previous versions of Android, backward compatibility. To help us keep track of all the different OS versions that matter to us as developers, Android has API levels. A new API level is defined when an Android version ships that contains changes that affect developers. By the way, I should note that this is my first time reading this book. I've always wanted to read this book, but never had the time. It's 3,000 pages, hence this project. and sharing it with the world in an audiobook slash, I suppose, video book format. I'm surprised with how good it is. Back to the paragraph, back to the book. To help us keep track of all the different OS versions that matter to us as developers, Android has API levels. A new API level is defined when an Android version ships that contains changes that affect developers. When you create an emulator AVD to test your app, you will indicate what API level the emulator should emulate. When you distribute your app, you will indicate the oldest API level your app supports, so the app is not installed on older devices. At the time of this writing, the API levels of significance on most Android developers are API level 10, 2.3.3, API level 15, 4.0.3, API level 16, 4.1, and API level 17, 4.2. Although in your Android development, you're going to probably find 4.4 to be the one you want to develop for anyway, hence reading this book. Here, of significance refers to API levels that have a reasonable number of Android devices, 5% or more, which now includes 4.4. The latest API level is 19, representing Android 4.4. However, at the time of this recording, it is API level 23, I believe, with Android 6. Or was that Android N? It's either Android N in 24, Android N in 23, or Android 6 in 23. Dalvik. Dalvik is something that doesn't exist anymore. You probably are thinking of Dalvik as a village in Iceland. However, that however is Dalvik. Trying to be funny. In terms of Android, Dalvik is a virtual machine. Virtual machines are used by many programming languages such as Java, Perl, and Smalltalk. The Dalvik virtual machine is designed to work much like Java, like a Java VM, but is optimized for embedded Linux environments. So what really goes on when someone writes an Android application is developers write Java syntax source code, leveraging class libraries published by the Android developers and third parties. Developers compile the source code into Java VM bytecode using the Java C compiler that comes with the Java SDK. Developers translate the Java VM bytecode into Dalvik VM bytecode, which is packaged with other files into a zip file with the APK extension, the APK file. An Android device or emulator runs the APK file, causing the bytecode to be executed by an instance of Dalvik VM. From your standpoint, most of this is hidden by the build tools. You pour Java source code into the top, and APK file comes out the bottom. However, there will be places from time to time where differences between the Dalvik VM and traditional Java VM will affect application developers, and this book will point out some of them where relevant. Processes and threads. When your application runs, it will do so in its own process. This is not significantly different than any other traditional operating system. Part of Dalvik's magic is making it possible for many processes to be running on many Android applications at one time without consuming ridiculous amounts of RAM. Android will also set up a batch of threads for running your app. The thread that your source code will be executed upon most of the time is variously called the main application thread or the UI thread. You do not have to set this up, but as we will see later in the book, you will need to pay attention to what you do and do not do on that thread. You are welcome to fork your own threads to do work, and that is fairly common, though in some places Android handles that for you behind the scenes. Don't be scared. Yes, this chapter threw a lot of terms at you. You will be going into greater detail on all of them in this book. However, Android is like a jigsaw puzzle with lots of interlocking pieces. To be able to describe one concept in detail, you'll need at least to reference some of the others. Hence, this chapter is meant to expose you to terms in hopes that they will sound vaguely familiar as we dive into the details. Choosing your IDE. Before you go much further in your Android developer endeavors, or possibly endeavors depending on, actually, that's the end of that chapter. And that's all we have. I'll see you next time. Bye-bye.